SpaceTime with Stuart Gary.
NASA has formally commissioned its latest dish at the Canberra Deep Space Communications Complex near Tidbinbilla. The new 34-metre antenna, DSS-36, is part of a $120 million upgrade by NASA to increase capacity at its Canberra facility by building two new dishes, the other being DSS-36's twin DSS-35, which opened 2 years ago. The new dishes join two other 34-metre and one 70-metre operational parabolic antennas at the complex, designed to provide telemetry, radiometric tracking, spacecraft command, monitor and control functions with the American Space Agency's fleet of spacecraft exploring the solar system. A sixth dish, the 64-metre CSIRO Parkes radio telescope, can also be plugged in to the Deep Space Communications Network when needed to increase capacity. The Canberra complex, which is managed for NASA's Jet Propulsion Laboratory by the CSIRO, forms part of NASA's Deep Space Communications Network, which also includes 5 antennas at the Goldstone Tracking Station in California's Mojave Desert and a further 7 dishes at the Madrid Tracking Station in Spain. The Canberra facility also works closely with the European Space Agency's new Norcia Tracking Station north of Perth to provide support for ESA missions. NASA's Glenn Nagel says the new antennas already started tracking dozens of operational missions across the solar system.
So this is sort of a combination of 6.5 years actually to build 2 new dishes here on site, and we're now launching our brand new dish, Deep Space Station 36, our new 34-metre beam waveguide antenna. So it's kind of grown out of the ground over the last few years. A lot of the electronics are all housed underground in a big sort of concrete cylinder, and then you've got the big dish on top, beautiful white parabolic dish that can communicate with spacecraft right across the solar system.
Now, these aren't little things we're talking about. These are humongous, and I think that's a correct scientific term there.
This new 34-metre diameter dish, which weighs just the dish is 139 tonnes, so they are sizable bits of machinery, has this really great capacity with additional surface accuracy, picking up very, very weak signals, high sensitivity. It has a first stage 20 kilowatt transmitter that will be upgraded over the next couple of years to increase capacity again for higher transmission rates, and it's very sensitive in the Ka band radio frequencies, very high radio frequencies. And this is something that all missions are really asking for now. They want to get more data back to Earth, so you have to work in higher and higher frequencies.
Tidbinbilla we used to call, I think it's simply referred to as the Canberra Deep Space Complex now.
Yes, so the Canberra Deep Space Communication Complex, so we're part of NASA's Deep Space Network, and we're managed on NASA's behalf by the CSIRO. So our job every day is to send commands to spacecraft so they know where to go, what to do every day, and then to receive all that data back, which we process, get off to the Jet Propulsion Labs in California. They then distribute it out to the science teams right around the world so that they can know what their spacecraft is doing. And then, of course, we share all the beautiful pictures and information to the internet so the whole world can share in the adventure.
This is part of a network involving 3 deep space antennas, one in Canberra, one in Goldstone, California, and one in Madrid.
Yes, so you need 3 sites around the world. So as the Earth turns, there's always one station watching every part of the solar system, because we have spacecraft everywhere. There are over 40 missions out there right now. They represent 27 different nations around the world. So we're not just handling missions for NASA, but for the Russians, India, Japan, all the European nations. So it's really busy out there, and it's only going to get busier, especially when we start sending humans beyond Earth orbit again in the next few years.
And just recently you're assisting with the European Space Agency's mission to land Schiaparelli on the surface of Mars.
Yes, so we were tracking both the orbiting craft, the Trace Gas Orbiter, and Schiaparelli. Unfortunately, Schiaparelli didn't meet the end that everybody wanted to, but they learned a lot from that, and that will put the Europeans in very good position to have a successful landing with their rover in 2020.
They have their own dishes in Australia. They've got one at New Norcia, and they've got others around the world as well. Why bring Canberra into it?
They're quite limited, the ones that they have. The Europeans primarily use them for relatively close communication activities, but when it comes to the really distant spacecraft, they always come back to the Deep Space Network around the world so that we can provide that communication link. But we do work very much hand in hand with our colleagues right around the planet.
And right now, MAVEN, of course, is making news.
Yes, the MAVEN spacecraft is doing great studies of the atmosphere of Mars, learning about its composition, about how it's been disappearing over many billions of years. It's another indicator to the story of potential life at that planet. And we have really some incredible spacecraft. Juno is out at Jupiter doing great work. Cassini still operating out at Saturn after nearly 13.5 years now. And we're still talking to the Voyager spacecraft that have been out there for over 39 years now.
And New Horizons is only just 15 months after it did that historic flyby of Pluto. New Horizons has now only just finished sending all that data back to Earth.
Yeah, it was literally only just in the last week that we received the last data from the actual Pluto encounter, so it was a 15-month return of all that information. And now, of course, that's not the end of the New Horizons mission. It's now heading out to visit a Kuiper Belt object with the fairly unromantic name of 2014 MU69, but it will fly by this object on January 1st, 2019. So Stuart, New Year's Day will be right here tracking that spacecraft.
That's Glenn Nagel from NASA's Deep Space Communications Complex in Canberra.